Recently, scientists who are investigating deep space have witnessed a surprising phenomenon. It was a star with nothing special, like the nucleus of a star that had already reached the end of its life a long time ago. However, there was something intriguing about it. It is quite rare to find a star the size of the Moon that is about to become a pulsar without exploding. Hello everyone! This may certainly sound like a fictitious story or a conversation of a third-rate science fiction writer who has not studied astronomy. But this is a fact. Welcome to our Wikivedia Plus channel. Want to know more? So, it's time to start our video. Hello, I'm a white dwarf star. Recently, a team of astronomers led by researcher Hilaria Caiazzo discovered a small mysterious celestial body at a distance close to 130 light-years from Earth. On a cosmic scale, this celestial body is very close to the Sun. It is surprising that such an irregular celestial body has been unnoticed for so long. This celestial body was designated as ZTFJ 1901-1458 and officially classified as a white dwarf star. However, the characteristics and behavior of this star are completely different from the white dwarf stars we know. Before explaining what is strange about ZTFJ 1901-1458, let's review what exactly is a white dwarf star and how it is defined by modern science. In this world, there is nothing that lasts forever. This also applies to stars. The final destination of a star is determined by its mass. For example, supermassive and large mass stars go through supernova explosions and their nucleus shrinks to become a black hole or a neutron star. On the other hand, red giant stars give rise to white dwarf stars. A red giant is an aged star with a mass 10 times that of the Sun. When a star becomes a red giant, it begins to expand more and more, until gravity can no longer hold its outer layer. As the expansion continues, the outer layers melt like ice cream exposed to the Sun, leaving only the central nucleus. In this phase, the central nucleus is composed of relatively heavy elements such as helium, carbon, and oxygen. This central nucleus is the white dwarf star. A typical white dwarf star is half the mass of the Sun and is approximately the size of Earth or Venus, being an extremely stable celestial body of high temperature and high density. Theoretically, a white dwarf star gradually cools down and loses its brightness, but this takes billions of years. The most indecisive star in the universe. So what's so strange about ZTFJ 1901-1458? In a nutshell, everything about it is strange. First, what draws the attention of astronomers is the density of this star. This newly discovered celestial body has a diameter of 4,300 kilometers. It is slightly larger than the Moon and smaller than Mercury. In other words, this celestial body is the smallest white dwarf star ever known to humanity. ZTFJ 1901-1458 is the smallest white dwarf star, but it has a mass of 1.35 times the mass of the Sun, being the largest mass for this type of star. It is surprising that such a huge amount of matter is compressed in such a small volume. However, ZTFJ 1901-1458 does not stop there. According to specialized studies, this star is rotating at very high speed and has an extremely powerful magnetic field. These are characteristics found in another type of stellar nucleus, the neutron stars. The central nucleus, which becomes a neutron star, unlike a white dwarf star, does not melt slowly. But despite having enough mass to cause an explosive supernova, it does not have enough mass to collapse into a black hole. When a star approaches its death, if the central nucleus exceeds a specific mass, instead of becoming a white dwarf star, it collapses and becomes a neutron star. This limit is known as the Chandrasekhar limit and ranges from 1.38 to 1.44 times the mass of the Sun. Neutron stars are even smaller than white dwarf stars and are the densest celestial bodies in the observable universe, excluding black holes. The problem with ZTFJ 1901-1458 is that this white dwarf star is maintaining a delicate balance, exactly at the limit of Chandrasekhar. For this star to collapse and become a neutron star, it lacks just a little mass. It seems to be the reason behind its strange behavior. This star is like a high school student who simply can't decide where he wants to study or work in the future. However, both the first discoverer of ZTFJ 1901-1458 and Laura Caiazzo, as well as other specialists, believe that at some point the fate of this star will be decided. Perhaps at any time the collapse may begin. But this is quite strange. This is because normally the fate of a star's nucleus is determined quickly. That is, it will collapse beyond the limit of Chandrasekhar or remain as a white dwarf for billions to trillions of years. After all, what will have happened to this star? Even after spending a lot of time since the death of the progenitor star that gave rise to it, why is it that it is undecided to the limit? The Frankenstein star and its destiny. Due to its small size in relation to its considerable mass and other irregular characteristics, specialists began to consider the possibility of ZTFJ 1901-1458 having already collapsed. In addition, a theory arose that it may not be a remnant of fusion caused by a single star. Normally, a star's nucleus does not behave this way after melting. Perhaps in the past, ZTFJ 1901-1458 was not a single white dwarf, but two white dwarfs, and before that there could have been two normal stars with a mass several times greater than that of the Sun. The two stars were probably sisters born in the same interstellar cloud and orbiting very close to each other. Probably all the material was used to form these sisters, resulting in a star system without planets. The sisters were born and found their end together, melting and transforming into white dwarfs. Both white dwarfs had a mass 0.7 times the mass of the Sun. The two white dwarfs orbited one another in the same way as the progenitor stars, but gradually they were getting closer. Similar cases are known by astronomers, but are extremely rare. At some point, the two white dwarfs collided and merged, releasing part of the matter into the surrounding space. That's how ZTFJ 1901-1458 was formed and began to collapse rapidly due to its own mass, shrinking to its current size. However, this theory does not explain the reason for its high-speed rotation. The two white dwarfs, which orbited so close to each other, should have been quickly decelerated by tidal coupling. What the future holds for ZTFJ 1901-1458 is still unknown. This celestial body was recently discovered and we still don't have enough data. This unique Frankenstein star may be about to collapse and become a neutron star. Or maybe none of this happens and remains the most mysterious white sister in the galaxy. The most mysterious in the galaxy, with minimal size and at the same time maximum mass. Well folks, that's how we end our video today. Thank you all for watching. And I hope you enjoyed this video. Astronomers will continue to observe ZTFJ 1901-1458 without a doubt. Perhaps the fate of this star will be decided soon. Will we witness this unique phenomenon where a type of stellar nucleus transforms into another type? We'll find out soon. And we promise to regularly bring fascinating stories related to the mysteries of the universe and the surprising discoveries that astronomers and astrophysicists find daily. Don't forget to subscribe to the channel, leave your like and share on your social networks. A big hug and see you soon here on the Wikivedia Plus channel. Until then, bye.